Good morning, students. Today, I'll continue with exercise 1.3 of the chapter Relations and Functions. So, the second question is let x is equal to 3, 4, 6, 8. Determine whether the relation R is equal to x comma f of x such that x belongs to x comma f of x is equal to x square plus 1 is a function from x to n. Yes, so first we'll write the given part. So I'm writing the relation first, that is R is equal to x comma f of x such that x belongs to x, f of x is equal to x square plus 1. Yes. Next, what are we given with? The values of x. So x is equal to 3, 4, 6, 8. Yes. So now coming back to our relation, R is equal to x comma f of x such that x belongs to capital X. That is, this small x belongs to this capital X. So the values of the small x are 3, 4, 6 and 8, comma f of x. So they have given an equation for f of x. That is, f of x is equal to x square plus 1. So I am writing the equation here. F of x is equal to x square plus 1. Now we are given with the values of x, and using these values we have to find the values of f of x by substituting in this equation. So what is the first element here? 3. So when x is equal to 3, then I am substituting 3 in the place of x, that is equal to 3 square plus 1. So in the place of x, I am substituting this 3. So f of x instead of f of x, f of 3 is equal to, in the place of x I have substituted 3. So 3 square plus 1. So what is 3 square? 3 square is nothing but 3 into 3. So 3 3s are 9. So 9 plus 1 is 10. So in the same way, the next element, x is equal to 4. So in the place of x I am substituting 4. F of 4 is equal to 4 square plus 1. So 4 square is 4 into 4. So 4 4s are 16. 16 plus 1 is 17. So the next, x is equal to 6. So f of 6 is equal to 6 square plus 1. So what is 6 square? 6 into 6. So 6 6 are 36. So 6 square is 36 plus 1. So 36 plus 1 is 37. Next, what is the last element here? 8. So when x is equal to 8, f of 8 is equal to 8 square plus 1. 8 square is 8 into 8. 8 8s are 64. 64 plus 1 is 65. Yes. So now using the values of x, we have found the values of f of x. Now we'll write the relation. R is equal to how we have to write? X comma f of x. So the first element in the ordered pair is the values of x, and the second element in the ordered pair is the values of f of x which we have found. So when x is 3, our f of x is 10. Next, when our x value is 4, f of x is 17. When x is 6, f of x is 37. When x is 8, f of x is 65. Yes, now we have found the relation. So after that, what we have to do? We have to check whether this relation is a function from x to n. So we have to check this whether this relation is a function from x to n. So what is the condition for a relation to be a function? That is, every input must have a single output. So here f is a function, this x denotes the input, and this is our output, right? So in the same way, this is our input and we have to check whether this input has a single output. So here the input 3 has a single output 10. So 4 has a single output 17. 6 has a single output 37, and 8 has a single output 65. Since every input has a single output, this relation is a function. So we have to write, yes, the relation R is a function from x to n. That's all, students.